Hi, and welcome to part 3 in our video series where we teach you how to get started developing applications using Swim. If you're unfamiliar with Swim, be sure to check out our Intro to the Swim Architecture video. Also be sure you've watched the first 2 parts of this video series where we show you how to set up our demo application and review the Java side of the application. Links to all that in the description, plus we'll have links to our developer site and our documentation and how to contact us if you get stuck or need help. First, let's take a look at the 2 pages which make up the UI of this demo. The home page of the app is the plant status page. This page shows a list of plants along with the current status of a selected plant. The real-time current value of each sensor on the selected plant is displayed on the gauge graph. If there's any sensor alerts, the alert count will display on the center of the gauge. The history of each sensor is displayed in the line graphs on the right side of the page. The gauge and the history charts both use the Swim UI charting components to visualize data inside lanes of the sensor agents. Here we have our plant simulator page. You will see that we have a plant list on the left and a plant with some sliders on the right. Each sensor on our sim plant has a slider. It also has a randomly generated name and plant type. Select some random values on the slider and hit Create Plant. You see our plant appeared on the plant list to the left. If you move around the sliders, you'll see the leaves on the plant change colors from green to brown based on the sensor values. Now let's tab back to our main plant status page and you'll see that the new plant has appeared here as well. The gauge and the line chart should also be populated. You'll notice above each line chart there's a section labeled Threshold. Clicking that will pop up a dialog which allows you to change the alert threshold for that sensor. Threshold values should be between 0 and 100. You can also set all thresholds at once using the Set Alert Threshold button underneath the gauges on the left. If we put these 2 pages side by side, you can play with the sliders on the sim page and see the charts and gauges update in real time on the home page. Feel free to take a minute and play with this. Now that we have a good idea of what the UI looks like, let's take a look at the code which drives all that. First, we'll start with the folder structure of the UI side of things. All the files for the UI live in the UI folder in the project root. In this example, the UI uses vanilla JavaScript, CSS, and HTML along with the Swim JavaScript framework. The Swim JavaScript framework includes a number of tools and components which interface with the web agents on the application side of things to make it easy to use the data living inside your web agents. The main things we'll be reviewing here are using the Swim JavaScript client to connect to the lanes, and the Swim charting components to visualize the data. The main files we want to look at are index.html and sim.html in the UI root folder, along with index.js and sim.js inside the UI assets.js folder. If we take a look at the HTML pages side by side, you'll see they have some things in common in the head of the document. After defining some meta tags, they both include the same CSS and then include a few common JS files before including the main JS class files which are specific to each page. Then we have a script tag where we create a placeholder variable called window.page. This will get used to hold a reference to the JavaScript class which drives the page. We then define a start method which is called once the document body finishes loading. Inside that start method, we create and initialize the JavaScript class which will drive the page. Notice that we are passing this warp link into the class. This is the URL the page will use to connect to the Swim application. Since this demo uses Swim as a web server as well, we know the website and the web agents are all using the same URL and the same port. You will see this show up later as Swim URL in the JavaScript. After that, each page includes just the basic HTML markup needed to define the page layout. The JavaScript classes which drive the page will use and populate many of these elements with charts, lists, and values. Both the plant page class and the sim page class share a number of similarities, so we'll look at those side by side. First, you'll see we have a lot of variables defined in our constructors. These are placeholders which will hold references to links, charts, and HTML elements that we'll use later. Hopefully their names make it clear what each variable is a reference to. You will see we also grab the URL passed into the JavaScript class and save it as Swim URL in both classes. Moving on to the initialize methods, these methods are using the Swim JavaScript client to create a couple of downlinks to the aggregation web agent to get the list of plants and the list of alerts that agent has. In our last video, we covered a few types of lanes which a web agent can have, such as map lanes and value lanes. When creating a downlink to its lane, it's important to be sure you use the correct syntax, as map and value lanes are called a bit differently. Here, in both cases, we are opening two map lanes to get our list of plants and a list of alerts. Notice we do not open the links yet. This is because we want to wait and be sure the page is ready to deal with the incoming data once those links are opened. It's good practice to assign links to a reference variable so that you can close those links later on when needed. Let's move on to the class start methods. First, both classes open the plant list link, which will trigger populating the plant list for the UI. Then they both create a click handler to handle selecting plants in that list. So let's take a step back and look at what happens when a plant list link opens. When creating a link, we create a Swim node ref and then pass in the host, node, and lane which we want to create a link to. In this case, our host is the Swim URL, our node is the aggregation agent, and the lane is the plant list's map lane inside of that agent. It's important to note that we are using a downlink map since we're connecting to a map lane. When the link is opened, there are a number of methods on that node ref which will be called at various times. First, we see the didUpdate call. When a link is first opened, didUpdate will get called for each row of data that lives inside of that map lane. Once it completes loading that data, didSync will then be called because at that point the UI should be synced with the data inside of the agent. After that, didUpdate and didRemove will be called anytime a row of data inside of the map lane changes or is removed. With that understanding, let's look at how the plant list link handles all of that. As new data comes in and didUpdate is called, we store the plant data into an array of plants based on the plant ID, and then we add a new div for that plant in the plant list in the UI. DidRemove will do the opposite when data is removed. Finally, didSync toggles a boolean so that we know the list is finished loading, and then it selects the first plant in the array and opens the alert list link for that newly selected plant. The alert link here is much the same in that we have a didUpdate and didRemove call, which both update the UI with the changes. However, we do not keep an array of those alerts since the data isn't really needed for anything else in the UI. Going back to the start method, you'll notice that on the sim side, we have a few more things going on. We grab a few DOM elements, which will get populated with data later, and then we kick off this thing called main loop. The main loop will get called on an interval and is responsible for collecting the current form values on the page and sending those values into Swim using command lines. This little loop over the sensor list is our whole data simulator. That's all it takes. The other code in this method is to update the plant image on the sim page. So now that you've seen how things get kicked off and rolling on both pages and know where the plant data originates from, let's wrap up by looking at how the data gets visualized on the home page using the Swim chart components. The links for the incoming sensor data are created when a plant is selected via the SelectPlant method, and the list of sensors for that plant is also loaded. You will see there are a few things going on in SelectPlant. First, it clears out any charts which may be on the screen and closes any links which may already be open from previous selections. It also calls DrawCharts, which creates the gauges and line charts on the page. Let's take a look at what that method does specifically. The method first grabs a few DOM elements to work with and then uses the Swim gauge view to create the main gauge you see on the page and define the style of that new gauge. After setting the gauge title, the code creates a Swim dial view for each sensor and defines the default style for that dial. Dials are what make up the individual bars you see on the gauge on that homepage. After defining each dial, all of them are appended to the gauge view, and that is appended to the canvas on the page. Next, we create line charts showing the sensor history based on the chart list array. The following for loop loops over the chart list array and creates a new Swim chart view and child line view for each sensor and appends those new views to the page. Moving back to the SelectPlant method, after the new charts have been drawn to the page, we open up three new downlinks for that plant, this being plant info, its list of sensors, and its list of alerts. When that sensor list link finishes syncing, it will call CreateSensorListeners with the plant ID. This will set up the links to all the proper web agents for that plant data, so let's take a look at that code next. You will see we first close any links which may be open from previous plant selections. Then we loop over the list of sensors in the sensor list and create downlinks to the latest value, threshold value, and value history lanes for each sensor. Inside the did set and the did update calls for each of those links, we update the UI with new data sent in on those calls. So for latest sensor values, when did set is called, new data updates the soil dial value, the soil dial label, and the value shown over the chart history. When threshold values change, it will update the DOM elements with new values, and finally, when data points are added or removed on the sensor history, it will add and remove those points from the relevant charts. So there you have it. That is the high-level overview of our plant monitor demo. If you have any questions or comments or just need help, feel free to reach out. We'll have links in the description on all the various ways you can contact us, as well as links to our developer resources and documentation. Thanks for watching our video, and we hope you enjoy.